let's look at subsetting a matrix. A matrix now is being created here. So we have values from 1 to 10, and we're going to have 2 rows and 5 columns. So I go ahead to run this and get to see what we have. So now we have it. It's arranged column-wise. So to select individual elements using appropriate indices, sorry for that. So here, what we want to do is that we want to look at the second row and the third column. Second row, third column, because the two-dimensional object column. We have the rows, we have the columns. So that is not going to give us an error compared to what we have with the vectors. So the same thing goes here. We have the first row and the fifth column, the value that corresponds, that's at the intersection of these two is what we're going to get. So we'll get this 9. So if you look carefully at what we have, so this is the intersection between row 1 and column 5. So that's the value that's staying there. For the second row and the third column, we have this at the intersection. So, assessing entire rows or columns of a matrix, you can do this. All you just need to do is make the blank, give a blank value or an empty value to the column section that's after the comma. This is going to give you only a row. So, and the same thing goes for the column. If you don't want to return any, you're not specific about any row and you want to return all the rows, then you make the rows side that's before the comma empty, and after the comma, give the number corresponding to the index or that column.